for coming for this replacement class. So in order for you to hear, because we have the ACs on, so all of you need to be quiet so that you can actually hear what is actually being taught. And we're having a quite bad throat, we're talking very loudly. So if you want to hear, then you can actually be silent. So I've already uploaded the test one solution in Moodle, so you can double check. But still I couldn't finish marking, so most likely I have to attend on next marking. Come again? It's okay, I can get the things to the results. So the solution is that you can actually check. Okay, we are continuing in the part of looping. So next example, yesterday we did one example and today we're going to do another example. It's only through exercises you get used to doing this particular, you learn about loop. So today's example is write a program to find the largest element stored in the array that is stored in data memory locations from hex 10 to hex 5F. Now here in particular it mentions that in data memory location, so that means you have this memory location is in data memory, right? So what's the location? What's the location? X10 until X5F. So what is supposed to do with this element? Guys, I am actually asking questions here. Yes. What is supposed to do? Yes, we are supposed to find the largest element. We are supposed to find the largest element which is stored from X10 to X5F, right? This is the whole range. We have to find the now take note that now we are dealing with array. It's all the economic. So now we have an array here, right? There's an array of element in data memory. So you're supposed to find the largest element. So that is what the question is asking. Now how do we actually solve this? How do we actually find the largest element? Don't just think about the logical execution. We have a lot of data inside here, right? How do you actually find the largest element? That is my question.
You load the value to the register.
Okay, that means you load which value to working register. Okay? Never mind, just tell. If it's wrong here, never mind. It's not a problem.
Any value.
Any value, load any value and then
Compare it.
Okay, coming close. What's the logic? You have some values inside here, right? You're close. You got the concept of comparing. But how do you compare now? That's my question. Yes, Amani? Okay, Amani got it right. She said that you actually compare the current address with the previous address. And how do you actually do that? How do you actually compare? How is the step-by-step procedure? What are you going to do? What is the first thing you plan to do? Come again? Which one? Move what? Move which one? On the value or? You cannot move everything into a step. I'm asking the step by step now. How do you do? So you say this one you move into another. This is the limit right here. Can't see. So how do you do this? You're going to move the first element into one file register, and then what are you going to do with the next one? So you all say compare. Oh, you're waiting for me to write answer.
So, move the next value to
Yes?
move the next one to register.
Literal or the content of this one?
The content of this one.
Move the content of the first one to any file register, and then what do you do next? Compare with the
Compare with the
in the next one. So if this one is bigger than this one, what do you do? Move this one into this one, right? If it's not bigger than that one, what do you do? Skip and go to the next one. There you got the flow. Do you get the idea? Yeah. So whatever it is, the final answer we want is the largest element. So what we can do is, we can take one file register, we can maybe name it as array max or whatever you can name it. So what address you want to assign to this? X? X10 cannot. X10 is being used there.
cannot register.
This array max should be any other file register which is not here. Because this file register is going to hold the final, the largest element. F what?
F16. At bank F, address 16.
So you're going to choose this as hex 60. So the flow is, now another thing is, what are you going to do? So what's the first step you need to do is, you need to load the first element, or you want to start from bottom also, anyway it's the same thing. So you need to load, but it's easy this way. You can do it this way also, not a problem. So you can load the first element into array max, and then what you do?
Compare.
You compare with the next one. If this one is bigger than this one, you replace. That means the biggest one goes here. And then what you do, you increase the loop count and you compare with the next. But then if you notice that you keep doing the loop, how many times you need to do the loop? There must be a loop limit, right? How do you find the loop limit? From hex 10 to hex 5f, how many elements we have? Use a calculator to find out. Hex 5f minus hex 5f minus hex 10. What is in decimal?
79.
What is the decimal? 79 plus 1, right? So actually you have how many elements here? You have 80 elements. Do you all agree? You all know how I got 80 elements, right? So that means you need to perform this loop how many times? No, 79 times. Why 79 times? Because the first one I already taken and put that here. So I need to do for the remaining 79 times. So what is the loop limit? What's the loop limit? 79. The loop limit is supposed to be 79. Why? The reason is because we already deduct one. The one already they entered into the array max. So the looping you need to do 79 times. So the loop limit is decimal 79 and not hex 79. So another thing that you notice is, since we are dealing with array, you notice that we have to constantly go to the next element, right? How can we actually consistently go to the next element without us specifying each one of this address? What we can do? Yes, use FSR, use pointer. You remember in chapter 1 I did mention to you that you use FSR as a pointer, especially if it's in a table format. You all have also done in tutorial 2, right? When you want to copy from one array one table of array to another table of array. So you know that by using the FSR indirect addressing mode, it gives you the advantage of that you have the post increment or the post decrement. It automatically increases to the next address. What you need to do, you only need to specify the pointer to the first address. After that, it will automatically, as you use it, it will automatically increase. So that means we need to use FSR. So take note of that. So which FSR do you want to use?
Post increment.
FSR? That one, okay? Fine, we're going to use FSR1. Okay? Now where should FSR1 be initialized to? Now take note that hex 10 is already been loaded here. So, by right you should initialize it here, right? At hex 1. Does it make sense? Why not hex 10? Because hex 10 value already we will be loading into array max. And then we will be using the FSR to keep comparing with the subsequent elements. Are you all following? So what I'm doing now is, I'm trying to teach you all to analyze the question, how you can actually do. First you try to get the logic. Okay, how do you do? Okay, first we move the first one here, and then we keep comparing. That's what we came out with first, right? And then we decided, okay, if you want to do that, then we need one element to hold the maximum value. And we realized that we're going to keep comparing, which means we are doing a comparative loop. But then this loop is not going to go for infinity. There's a particular limit, right? So we need to know what's the range that we have. So how many elements we have here? -1, because 1 we have already loaded. So we have remaining 79. So we know that now we have to perform the loop 79 times. The next thing is, because we are dealing with array, we need to access the subsequent address, right? You cannot be each time changing the address. So the best way of changing the address in an element is by using FSR, because it automatically increases to the next one. You get it? And we also find out that where should we start to initialize from. Now with this knowledge, now you can actually start typing the code. Of course, earlier you came with the program flow. Again, what is the program flow? First, what do? You load the first element here. That's the first one. Second, what is the second step?
Initialize.
Yeah, second one, you should initialize the pointer. Where do you want to initialize it to? Here. What's the next step? Now you can compare. Remember, compare instruction is a double pair. So you always should load what first before you compare? What should you load first before you compare? Limit, no? You always want to compare the limit. It has the load limit. And then what will happen next? Of course, when you're comparing with the loop, what you are going to compare with the limit? The loop count. So you also must have a loop count initially. Remember, always a loop will have the loop counter and also the loop limit. So you're going to compare. So when you compare, which instruction that you're going to use? Skip is greater than or less than? Then it will be later like. When we write later, you can see it. So if this one is bigger than this one, what do? You take this one, you override. If this one is smaller than this one, then you skip, and what do? For both cases, even though if it's bigger, you swap and then you increase the counter. If it's not, you straight away skip to the increase the counter part. And then when you come back, what you need to always check before you compare? You need to always check whether it has been exceeded or not. So in other words, when you actually see the construct of the loop, you actually load, you initialize the loop counter and everything, then you initialize the FSR. Before you compare, what you should do is, remember yesterday's example? Before we actually compare, what we do? We actually check the condition first. Why we must check the condition first? Because here we have a limit. If it reaches 79, or if it exceeded 79, there is no point for you to compare. So that's why in this case, it's always best to check the condition first. Because in this case we are increasing from 0, we are trying to reach with the number of loop count. Yesterday we did some examples where we load like branch not 0, right? That one, the condition checking is at the bottom. When it's 0, it actually comes up. Or of course we can also use branch not 0, but you can use it on top. So there's a lot of ways that you can actually construct a loop. The only way is by you trying to experiment with it, different types of loop. Now shall we try to do this? Here's the part, right? So we're going to have our include part. So do we have data directives? What are the data directives that we have? We have array max. We actually assign set or EQU. Yeah, I already did that. What's the address?
60.
Is there anything else we need to define?
Yes.
What's that?
Loop limit.
Come in.
Loop limit.
Loop.
Limit.
Okay, loop limit. Before that, the loop counter. Loop counter. Which address you want to choose?
What address is not there?
Huh? 61. Next. 001. And then we want to define the loop limit. So we can put a limit. Is this set or EQU?
EQU.
Why is this EQU?
Because it's a value.
This is the value. What's the value?
4.
79. Is there anything else? So far that's all. If there's anything we can add in between. Next we have our program start templates. Is it okay? Again, don't worry about writing. Participate and take part in the discussion. If you want to write, you can take photograph also, no problem. Why bother? So start. What is the first thing that we did actually?
Clear.
Clear what? Clear what? Clear the pointer, clear the content of array max. Clear array max, then clear the loop counter. So many things, right? The array max actually we don't have to clear. The reason why is because you're going to load the first element into array max, right? So that's not a problem. The loop counter, you must make sure that it is cleared because you're going to use increment later to increase it by 1. So that one you must make sure that, of course by default everything is 0, it is to make sure. So what is that? You're going to clear F. This clear F has how many fields? 2 or 3? 2. Clear F I. What's next? We clear the loop count ready. What's another first thing we do with the array max? What we do with the array max? Yes, we load the first value inside, right? So how do you do that? You can use move FF, right? You're going to move the content of x10 to array max. Is everyone following? Is there anything else we need to initialize? Bank. Why bank? Not using bank. Another one more thing we need to initialize. Yes, the FSR. Limit we will be using whenever we want to compare. Okay. Now we are dealing with the initialization part. One more thing which is missing is the FSR. You need to initialize the FSR. So this we are using FSR1, right? What is the address I should initialize it to?
11. Next one.
X11. Is it okay? It's already pointing at X11. So is there anything else you want to initialize?
The word FSR 1
There's two ways you can write one. I told you you can write FSR1 or you can write 1. You can write also 1. But I prefer to write like this so it gives us a clearer picture of which FSR. But you can also write 1. We are using FSR1. Then the question, is there anything else we want to initialize? Yes? Which part is loop counter? Loop counter is not seen there. Loop counter is the one that keeps track of how many times to loop. So of course visually you don't see that because it's a loop counter. It keeps track of how many times you need to loop. It's about this one. This is what we're going to keep track. This is what kita can compare with the limit. So this one should start with 0. It keeps track how many times you are looping. We want to loop 79 times. So that's why we have the clear idea. No, any name you want. You want to use loop counter or whatever. It's up to you. All these names you don't have to follow. So some students, they're very obedient student. Even exam also they still use array max. Even though ask minimum also array max. Why kenapa? No. So write array max, I only use array max. So you don't have to, all these things you can actually give your own name as long as it makes sense. Okay? If you think I doesn't make sense, you can put loop counter, how in the previous examples that we have done. Is there anything else we want to actually initialize? So the initialization part is done. So what's the first thing that we do just now I mentioned? We're going to check for the condition first, right? So we're going to use compare. So whenever you want to use compare, what you should do, compare is a double pair, right? So what is the first thing you should do? You have to move the limit, right, to working register, and then now you can actually compare file register. So now which compare actually you want to do? Remember, you're going to compare, what you're comparing with is, you're going to compare I with the content of I with working register. So what is the sign that you want to use here? Skip if what? Less as. You can use skip if less than. That means as long as I is less than 79, it will skip. When you skip, you can continue the program. If it's more, it will go here. Right? This is part you can go to exit. You all get it? Yes. So this is you're going to compare with I. So you're going to check. I is less than 1, you skip. So if it's not less than, which means it reaches 79, means it won't skip, it will go here, which is we supposed to exit. So we can readily write here, go to exit. You all follow it? Now if it's less than means, now we are continuing with the program. So what are we supposed to do? We are supposed to now the condition is fulfilled. That means the loop is still valid. So what's the first thing we should do? We should compare, right? We should compare array max with the content is pointed by FSR 1. So again, you need to compare now. So you need to compare between array max and also FSR 1. So which one you want to put inside working register? array max or FSR1?
FSR1.
So how you want to do that?
No, bracket FSR1.
What did you say the answer? Move FSR into working register. Can I just follow you what you want to see? How you move that? Move FR. Increment 1, 2. Okay, register. And then now we can compare it. Compare file register. Now which one you want to use? Skip if less than or skip if greater than?
So you
Yeah, I also don't remember, so I'm skip if less than. So when you comparing this one and this one, you are actually comparing. Can I erase some part from it? You are comparing array max with working register. So if you say if this one is less than this one, you skip. That means if less than, you actually going to skip. If it's not less than, what are you going to do? If this one is not less than this, means what? This is bigger than this. So what are you going to do? Move this one to here, right? So this is you're comparing with array max. So we're going to use this less than. Array max is less than working register. Currently that's what is happening here. If array max is less than working register, it will skip. That means what you're supposed to do is skip part here. You're supposed to move the working register here. If not, you're supposed to increase the counter, right? If you do like that, you find that the order is a bit kachiao. But still no problem. You still can alter the kachiao. So what I'm trying to prove is, whatever that you put, bully kautim. Whatever you do can kautim one. So whatever that you give, let's try to kautim it, whatever you have given. Okay, if array max is, if it's less than working register, what is inside working register? Here is this element, right? So if it's less than, by right, this is bigger than this. So you should move this one to here, which is this portion here, right? So what is supposed to do? Move FF. Because you are using okay, register to array max. This one if it's less than, that means if it's not less than, that means this is still bigger. So you should skip and go to increment right. But since if here you put the instruction increment, later because it tends to go in a sequential manner, you know. Go like this, right? Let's say if it doesn't skip, it will go here. Then it will execute this one. Because after this, you're going to write the increase. So it will increase again. So what we can do is, yes, we can actually use branch. Skip. After you have done this comparing and converting, what is the next step? What's the next step? Yes, yeah. Because you have your task to do is compare. That's what you're going to do. Each time you're going to compare. If it's bigger than you exchange. If no, you skip. Skip means what you do? You increase the counter. Increase the counter and also the FSR one already increased here automatically, so that's the advantage. So here, what you can do? You can increase F. This is I. E. So this skip should go. Where should the skip go? It is skipping. It should come here. After this, what we are supposed to do? There is an unconditional branch, right? Where should we branch to? Where should the check go? Yes. Check should go here. Why? Because in between you have used working register for something else. So the check come here. Is the program complete? Is the program complete? What's missing? Yes, the exit. Go to exit. Where should the exit come? Exit here. So let's try to analyze the flow of the program. Is this one clear? This is clearing the loop count. So initially the loop count is 0. You move the first element into array max, and then you initialize the FSR1 to point at hex 11. This is the initialization part done. So now is the main loop that's going to start. The first thing is you're going to check for the condition. This part you are checking for the condition. Is it still within the limit or not? This you said skip if less than. So that means as long as it's valid, it will skip. Skip means it will execute. So let's assume that if this one reaches 79, so is it smaller than 79? Alright. So it won't skip. So it will go to exit and it will end the program. That part clear, right? So now let's assume that it is less. Now it's actually 0, right? 0 is definitely less than 79 because here is decimal 79, right? Comparing with. So it's not 79. So what you do? You move the element which is pointed by FSR1. FSR1 is pointing at hex 11 to working register. After you have moved, what happened to the pointer? It automatically goes to the next. It keeps pointing to the next one. Now here you are comparing skip if less than. You are comparing array max with working register. If array max is less than this one, you skip. If this one is less than this, which means this is bigger. So what you should do? You should move from whatever is the working register to array max. That's what we are doing. Because you skip, you move to array max. If it's not, by right you're supposed to skip that transfer part and you should go to increase the loop counter. But if you write loop counter here, it disturbs the flow. Just imagine if you write loop counter here. And you know that after you have, in the case of where working register is larger than array max, you need to copy or transfer the largest element to the array max, right? And after this, you need to increase. So if you write increase here, and then again you're going to increase, it will double increase. So we want to make sure that the flow comes properly. So what we do, we use branch skip. So to make sure that if array max is actually smaller than, if array max is not smaller than working register, you are not going to skip. So you will go here, which is increase. If in the case where working register is actually larger than this one, you will override. You will move the largest element to array max, and then you increase the loop count by 1. So either one case, you automatically always will increase the loop count by 1 at the end of the operation. So after you increase, you always go branch check back with the loop limit. So when you're checking here, okay, now it's 1, you increase by 1 already. So it's still skip if less than, yes. So where is FSR1 pointing? It's already pointing to 1, 2 now, hex 1, 2. So you're going to move hex 1, 2 working register. Okay, you're going to compare. So the same thing, the whole thing is going to go until you finish the whole loop. So the best way of learning this is by changing these conditions. You can change this condition, you can actually put the checking down. If you want, you can actually use this to check down. You can start with the loop by loading 79 into the loop count and decreasing one by one. You can also do that, right? So now, try to explore with it. Try to explore, so then you can actually learn a lot. Any question on this? Yes.
Instead of writing the branch scheme, can we just leave that lines out?
Okay, the thing is, if you don't write anything here, what happens is, in the condition where the array max is bigger than working register, it won't skip right. So let's say if you don't write anything, so let's say I just put NOP here or nothing. The PC will come here and it will go here, it will continue like this. So if it goes in this progression, it is wrong, because it will execute move FF. So we don't want that. We want, if array max is larger than a working register, we want it to increase. So that's why we actually putting this branch skip. If you don't put anything, remember PC will go sequentially down. So it will execute move FF and then it will execute the increase F. So then your program will become wrong. Any other question? By the way, this way of doing is known as bubble sort. We have learned it in C programming. Bubble sort. Bubble sort. You load one element, you compare. If it's bigger, you override. Compare. At the end of all this thing, the largest element will be stored inside. This is a very, very famous and the most simplest data structure algorithm. For CC students, I think you all learn data structure and algorithms. That's the most easiest one, right? Bubble sort. Others we have tree and all these different things. For information data algorithm and structure, you have learned the subject, right? Any question on this? Yes. Branch which one? Yeah, then you have to make slight changes. So that's what I want you all to try. It will be slightly different. Sometimes when you do certain loops, you will find that you will end up with it. You try to do the loop, but you find that, hey, this one, So you try to change. So make mistakes, then you can learn from mistake. So all of you have already know how to use MPLAB. So try to actually see whether is it going. Of course, whenever you use MPLAB, you don't have to take such a large element, because I know you don't have the patience to wait until 80 loops. So what you can do, maybe you can take 5 loops. So make it smaller. Size it down, downsize it. Just 5 loops. Just so that you can see how the progression is going. 5 loops, okay, you have the patience for 5 loops. So you can actually see things like that. Okay? What are the real? So if you want to do something like that, let's say you put in some dummy values inside. Put in some dummy values.
So while doing writing the program, you don't have to say initial.
In this case, no need, because this program is actually the algorithm is such where irrespective of whatever you write inside, it will find what's the largest element. So some students they'll be in anxiety. So there's nothing inside here. There's nothing inside here. But it doesn't matter, because whatever's inside here, this program will find the maximum value. So that's what I want you to try. Use MPLAB, maybe reduce this loop until 5 times. Put in some values inside. Yeah, I know you'll do the easy one. 1, 2, 3, 4, 5. And then when you look, you'll find what is the largest element. So try to do. Sometimes whatever program I do in front could be wrong. So you can prove me wrong by doing, sir, what you did is wrong. For what? For you to learn. Take note that I am also human. I also make mistakes. So you can feel free to actually correct me if I make some mistakes. Sometimes it's a little difficult for me to see what mistakes I make. So you can actually explore, do MP Lab and learn. So any question on this? Yes. This one will automatically go down. When it comes here, the PC will keep going down. Yeah, label is not instruction. They are just label. It doesn't affect anything. Always the program goes in a sequential manner until the point you see something like this or this. This instruction, this instruction, this instruction, this one, and this one changes the PC. Other than that, the program goes sequentially like this. Unless like this one skips, okay, come here. Do this one, okay, skip, come here. Is there any skip? No. Go down, branch, okay, then go here. So like that. It will go down until if there's any instruction which changes the PC or makes it to loop. Fine like that, definitely not like this, like Musala. Fine like that, definitely be more harder than this. I forgot, I didn't see the final paper yet. Then I'll know what is that. Come again? So I haven't seen the question yet. The finals will be fine. No, you see, the matter is, if you understand the concept of, you see, this loop, definitely final will have loop. Definitely will have loop. It's no way that it's going to run away from loop. Definitely will have loop. So that's why I'm telling you, the only way is by you practicing. You spend time, do different loops. Never scared this. So definitely you have to practice. There's no other way to do it. So the thing is whether you want to take time and do. And another thing, just a gentle reminder. As I mentioned earlier, whatever doubt that you have in the week saved, just ask back the same week. As I mentioned, do not wait until last minute, because what you tend to do is sometimes also unfair to me. Because we'll come towards the end of the semester. There was one of the students actually came. That time, the first semester, I don't know whether I told the story or not. I told the story right. He came. I told the story right. So the student came at the end and actually asked me to explain everything. So it also frustrates me in the sense that, how am I supposed to sit you and teach the whole semesters in the limited time? So, and I also have already told you in advance that my schedule is really, really packed, and I've been very, very busy with a lot of projects and consultancy projects. So that's why I'm encouraging you every week try to ask. I'm already sharing the code. Like this semester, I'm really doing a lot of things. Only thing the video I haven't uploaded yet. Because I've got to convert the video. To load takes one thing, to convert takes one thing, upload maybe next year. Until now, the videos that we have taken up to this point, it's 55 GB. So just imagine. So anyway, it will happen, don't worry. But then still, I am actually sharing the code. I made your life a bit more easy by sharing the code so that it's easy. But I don't want to pamper you too much. There will be a point I won't be able to do that. So you all try. We already did on board. Right. Is there any question? So this is the answer. Is it same? It's a bit different. This one using skip if greater than. So this is one example. What's the time now? Okay, any questions? Otherwise, I think 40 days. Yeah. Okay,